Okay, so if we are looking at this right triangle XYZ, again, in a right triangle, we know that there are two different sides. Well, there might be three different lengths, but there's two different sides. So we have the hypotenuse and the legs. So the hypotenuse is always the longest side, and it's opposite my right angle. And then the legs are the other two sides. So when it comes to when we're working with these trig ratios, it's really important that we know what the hypotenuse is and then what the legs are, but then more specifically, which leg it is in relation to the angle. Is it the opposite leg or is it the adjacent leg? So I'm going to focus on angle Y to start. So if I'm looking at angle Y, I know that, again, 29 is my hypotenuse because that's not changing because it's opposite my right angle. So now if I'm looking at angle Y here, angle Y is formed by the sides X, Y, and YZ in my triangle. So since it's formed by X, Y, and YZ, XY is one of the legs. That means that that is my adjacent leg because it's one of the legs that forms the angle. And then the opposite leg is the one that doesn't touch it. So in this case, it's XZ. So again, these are all in relation to angle Y. And the legs, they change based off of the angle that you're working with. So let's say now I asked, what's the sine of Y? What's the cosine of Y? And then what's the tangent of Y? So remember, best little trick, SOHCAHTOA. So my sine, my opposite leg over my hypotenuse. So in this case, my sine of Y is 20 over 29. I know something that can get a little confusing is some people think that the hypotenuse might be like an adjacent leg, but that is never going to be the case. So if it's either a leg or it's the hypotenuse. So the hypotenuse is never going to be considered an opposite or an adjacent for trig. So I have that my sine is 20 over 29, and then for my cosine and my tangent, we have cosine is the adjacent leg over the hypotenuse, so in this case it's 21 over 29. And then for our tangent, we have that it's opposite over adjacent, so that is going to be 20 over 21. Okay, and again, these are all for Y. So now let's say that I change this, and now we're looking at angle X instead of angle Y. Or sorry, not angle X. Let's do angle Z. So if I'm looking at angle Z, again, that 29, that YZ, that's still the hypotenuse. That's not going to change. But these legs, what happens is they actually end up trading spots. So if I'm looking at angle Z is made up of segment YZ and XZ. So in this case, looking at angle Z, XZ, the length of 20, this is my adjacent leg. And then 21, that's my opposite leg. Okay. So now if I want to know the sine, cosine, and tangent of angle Z, we now have different measures that we're working with in relation to that specific angle. So the sine of Z is opposite over hypotenuse, so this is going to be 21 over 29. And then my cosine, adjacent over hypotenuse, so this is going to be my adjacent leg of 20. Ooh. There we go. So we got 20 over 29. And then my tangent is that opposite over my adjacent. So that's going to be 21 over 20. Okay. And again, these ratios, again, you're using the same three numbers, but they will change completely based off of which angle you're working with. And a couple now other small, quick things. Again, the hypotenuse is never going to be an opposite or an adjacent measure. It's always just the hypotenuse, no matter where it is. So normally we are not going to be taking like the sine, cosine, or tangent of the right angle. We're only going to be working with the other two angles. So that's the big thing. And then just remember that the relationship and the order of everything matters. So everything changes based off of which angle you're working with.